speak is not in the order as Tim White has been speaking about how we can construct the better world for the future, but I try just to speak with you about the needs as far as energy is concerned. I'm currently the president also of the European Academy of Science, and last week I was involved in the G7 meeting where the key target was to discuss the One Health of our planet. And indeed, what we could hear there is 2020 world is taken aback by a pandemic. It is turning into an unprecedented crisis in people's lives and economy. And for the motor and the driver of this is energy. And the world concerns over energy security and environmental issues due to fossil fuel consumption. And so it's urgent to see how we can really drive for a sustainable world where energy is the driver for a broad range of applications. Therefore, the biggest challenge that we identify in this meeting is that we have to go for smart technologies, sustainable power sources that can back up the electronics in an unconditional manner. The situation is that more and more we have to try to look for new platforms of self-power technology operating in any external power devices. This is what people are looking for, and this is why I gave the title of my talk and today, and I would like to share with you. And we can just go back 40 years ago, and you can see how we communicated, how really we could require energy to communicate and to transpose the ideas. We use our secretaries and the paper office where we took the notes from what we would like to do and make. And when we would like to see something, we have the CRT's tubes to look at the television with a lot of consumption. And of course, when we'd like to get some type of information, when we go to a restaurant or when we go by train to home or to the school, what we have typically to get this type of information is just magazines, newspapers, and so on. Look at the 2020, where we started all this movement to communicate it and to pass this information on the offices. We just not use paper office. We just use displays where we can communicate it. And at home, we use fantastic flat panels, displays. At the restaurants and at the trains, what we use the mobile phone to communicate. And this is a mobile thing that requires to be powered. And at school, I think most of the people, we learn via a computer screen, not via a paper office, as it was in the past. So indeed, what we have today is something else that we have to intercommunicate and control everything that surrounds us. And it means that we have to look, whatever the interface that we are looking for, we need energy. And this energy to communicate it is something that we have to see how we can exploit. And indeed, we know that as we are living today, electricity sector is the largest source of greenhouse gas emissions. And so this is something that clocks. If we go for, as I told you, for One Health planet, it means that we have to try to look for the disease of our planet. And the disease of our planet is that not only we are creating gas emissions, but we have a finite supply of fossil fuels. They are responsible for our comfort. We have more and more cars, we have more and more usings, and so more and more CO2 fingerprint going there. And all this, the consequence of this effect of the CO2 emission is the global warming that we are suffering, with disasters appearing over all the planet. So it's nothing that we cannot think and we have to avoid. So how we can really go further? I think we have to go what we call green energy. And green energy means something that could be sustainable and could be, of course, the correct answer not only to the demands of CO2, but also to the frustrations that we have with the recent or existing energy resources. We can see that either we have problems, political, geographical, political problems, like in the coal reserves. We know the USA has the largest coal reserves, with Russia coming in second and China in third position. And also we know the oil reserves. We have the countries like Venezuela, Saudi Arabia, Canada, and Iran. But even so, they are limited no more than to 50 years. This is what we expected if we keep the consumption. But all of this together makes that we increase the CO2. And the CO2 is also responsible for the sea levels rise. And of course, the other demand that you are looking at in Europe, for instance, is the gas reserves. We have this problem that everyone hears about, the war in Ukraine, and we have this gasoduct to bring the gas. But the gas supply also is limited. We think that it does not go over 70 years. And so even all of this combined makes that we go for extreme weather changes. So this is something that is killing our planet and promoting what we call the global warming. And therefore, whatever we make, maybe all of the existing energy resources, the only one that is expected to go over the 50 years are the coal. But the coal creates a lot of, not only environment, but health problems to the people. So we cannot sacrifice our planet. And we know that due to the science, we gave giant quantum jumps towards the comfort and welfare of the people. It was impossible without science. We reached the last number 1 month ago of 8 billion people in the planet. So we have to look for this big issues that we have connected with our planet and look what we have, and to giving comfort and going for what I say, for this self-sustained power platforms that I can take it in my pocket and I can move for whatever I want. We go from very low processes, which means that we spend less than 10 watts, which are the portable things that gives comfort to our lives, that we can really accommodate in our bodies or in our systems. And then, of course, there are the other region that concerns the high power energy requirements. And this means that we have a plethora of applications that go from 10 nanowatts, that is for ultra low power consuming devices, just for alert applications, for standby applications. We go for just a quartz oscillator consumes around 100 nanowatts. And this is the things that we go up to 1 milliwatt, where we have the miniature FM receiver and we have the transceiver. This is something that impacts in our lives, because means that it's the interfaces of communications. Then above all these values, we starting getting problems of high power consuming and systems, more robust systems that require, of course, other type of attentions. And so other type of ways how we can increase the, like our laptop. Our laptop, the consuming is around 10 watts. And of course, the desktop that we may have in our houses, we may alert for something around 100 watts consuming. So indeed, when you go to look for the energy and what are the prospective efficient ambient or environment sources for energy harvesters, which may lead what I said at beginning, self-power technology, we have to see what we can convert. We have the electromagnetic energy, we have the mechanical energy, and the thermodynamic energy. How we can really convert this to what we want. And we know that this type of self-power technology means that either I can convert temperature by using the Seebeck effect, and so I can take what we call the thermoelectric effect. We have the photovoltaics, is the conversion of photons directly on energy. We have the conversion of the mechanic energy on electricity via piezoelectric materials. And of course, we have another fourth approach. This is via RFI. So I can capture the energy from the radio waves that are circumvent us. And this means that I just need to have an antenna to capture. And for ultra low consuming, this could be an approach. But whatever the type of energy of one of these four sources, and this one is really fantastic because I can power most of the devices in the nanowatt ranges. It means that I must have some conversion circuits. I must have some electrical circuits to protect and to control the energy that is supplied, or to convert them in the form of energy that I want. So this means that I have to go for power management controls, and of course we don't have sun all the day, so we must have some problems and something concerning energy storage. This is what we call the batteries and supercapacitors, where I can storage my energy. But today are other things. When we speak about hydrogen, this is a way of to storage energy. Biofuel, I can make a solar refinery, and so I can convert and use the energy supplied by solar means and conserve and storage this energy. And whatever the type of applications, I need to have external sensors and the load. Why? I need to have the sensors to know when I should try to use this type of energy. So I should know today. I cannot have, as in the past, a continuous connection between the power source and the load. So I must have sensing elements that just connected when the energy is demanded or required. And of course, in this type of applications where we are looking is something that is coming up when we are speaking about this self-sustainable smart platform. We have applications in the field of wearable electronics, health monitoring. This is maybe the giant step that we can go, because I can have sensors spread over my body, including in my skin, and of course they can control and monitor a lot of things from me: the temperature, the humidity, the bioproducts that I'm producing when I'm running, for instance, and also the cardiac rhythm. And this is something very important for us. And I can make it in my clothes, so it means that everyone should be portable. But I cannot connect the peoples I cannot plug in on existing sources today. And of course, we have the sports and lifestyles, the smart package. This is something that will impact very much in the quality of our comfort in our lives. Smart packages not only for tracking. I need to track the packaging, but also to know what is the status of the smart package. This is something that myself and my wife, we developed, which is on this paper electronics. And by the way, it was considered one of the 20 best inventions forever. So I'm very proud, because the magazine Ericsson from Finland, they elected the 20 best inventions of ever. And so they elected our invention that because it will impact on the health, it will impact on the food. And we need, of course, on impact on the control of the quality of the water that you are drinking. And they consider the oldest guy Tesla, and today Elvira Fortunato, that is my wife. Anyhow, we also have to look for the security systems. And another thing that we are increasing the demand as far as power is concerned is for automobile. And here we know what is the solution, is the electrical car. Maybe not what we are doing today about electrolyte-based batteries, but solid-state batteries in the future, by sure. And of course, when we go to look of all these demands, we can see, of course, the 4 types of energy that I spoke before. We have the mechanical the mechanical responsive energy harvesters. They accumulate mechanical energy in any forms and convert it into electrical energy. The thermal energy harvesters accumulate temperature gradients or variations and convert into electric energy. You can see here examples. The photovoltaics, you can have it, and they can be wearable as well, and just they convert directly the photons on energy. And we have to say it's something that was in the mind of creative people. The first solar jacket was made by Tommy Hilfiger in 2014. So 8 years ago, he was already thought. And of course, we have the radio frequency harvesters, as I spoke, where we can, of course, pick up the energy that we have in the cloud and use it to power our systems and units. So let's start by speaking about the mechanical responsive system. On this smart energy challenges, the idea, of course, is to convert the mechanical response when I'm walking, when I'm moving, and to convert this type of energy, mechanical energy, and make it affordable. And so it means that what I try is to convert a mechanical movement. So I have a movement when I'm walking and I'm disturbing, and this one I can, of course, convert and stabilize using the proper electronic control, and try to see how I can convert the pressure. And the pressure is completely different when I'm moving from a man, a woman, a child. And you can see this is something what we can generate. But you can have more or less an idea. Each step that you can generate about 5 watts and this is something very, very, very important and very relevant for us. And of course, on this type of conversion, you can see when I'm trying to move, for instance, I can make the floor, and I can in the floor I can define by using different type of piezoelectric materials. I can generate this energy, and this energy, of course, can be accumulated and of course used on the environment by using near field process communications to power a lot of small devices. Those are examples of the piezoelectricity, how I can convert. Even I can make codes and encrypting information by using this type of combinations. This is the outcomes of a quite recent paper that we published. And the idea is that not only we produce energy and we can take profit, but also I can encode the information that I'm trying to receive. This is an example where I can have different sizes, and by playing with the size, like as it was a barcode system, as I'm moving, I can make different type of combinations of ones and zeros, and this could be used as something very, very relevant for us. You can see that how we can do. Even I can make some type of combinations. This is something that we are doing in our laboratory, and I can even try to manage and try to promote by combinations the different type of colors by just combining the output voltage that I'm having, and by combining the type of PS, and I make this type of combinations, and of course I have an output. Everything is analogic and can be, of course, of great relevance. So just to say that the energy is not only relevant to power as a power source, but also I can use for digitalization of the information. So let me pass. So this is something that, of course, can impact. The other thing is the neuroprosthetics that we have. So we can take advantage of the muscles, of the movement of our muscles. And from this type of movement, I can, using triboelectric nanogenerators, I can use, of course, what we call the vagus nerve stimulations by electrical stimulus difference in neuronal structures. So I can have it some type of membranes, and they can work like triboelectric generators, and the movements of my body, of our muscles, will supply the energy that I may require to power whatever I want. And the best example is for an athlete. I can take advantage of all the movements of an athlete, and from this, they should be more than enough to power not only any type of electronics that I have in my body, but also to sustain the required energy for further development. So this is something that we believe we are not so far exploiting this mechano-responsive power sources, and I believe for the comfort of our own comfort, this is a must for the future. Then we have the thermal energy harvester. This is a very old idea where I can convert thermoelectric, and indeed what we have is the hot generated by our electronics. I can reuse it and try to reapply on the loop of the energy requirement to power different type of sources. So this is, of course, different type of approaches that we can do it. And of course, I can try to create the gradient between the body when I'm running and the environment. This is more than enough to generate some nanowatts of energy that may power several types of power fields. And then we have the photovoltaics. Everyone knows about the photovoltaics. The present limitations of photovoltaics is that we have to increase the efficiency of these devices. And to increase means that we have to think in different architectures. We cannot keep the same type of architecture. We must improve the solar cells efficiency, because the cost of materials is in the limit. And as we are making and giving more comfort to the people, we cannot have slaves, so we have to improve. And indeed, in our lab 2 years ago, we identified a new type of strategy, changing the design and the architectures of the devices. We could double the efficiency of the existing solar cells, and reducing also, of course, the amount of material that we require to make the same. This is the type of architecture. This is something that is impacting. We have more than 3 million of viewers of this paper, because the strategy is changing the design and the architecture, try to improve and capture as much as you can the photons. And this means that I have to increase the pathway how the photons are captured by the surfaces. So I can, using with this design, I can increase the efficiency. And by increasing the efficiency means, of course, I'm in the right track. And moreover, in most of the applications, as I told you, where we need to generate some energy, of course, our idea is to use on and produce solar cells on disposable platforms, as we did on the paper platforms. And finally, we have this radio frequency harvesters, and this is something that is very important. I can make it. I like very much the concept, because is to capture the what we call noise, or what is around us, and the idea is how I can capture via an antenna, and how I can transmit this energy, and how I can really power the system. All this. I can design the new circuits, and this is something that was the basis of a European Research Council grant that we got. And the idea is I can design the circuits, and using the LIG, the laser-induced graphene, I can make the sensors, I can make the electrodes, and I can design the circuits on paper and anything and any surface that I can find with electricity. So I can make absolutely fantastic printing circuit boards where I can capture this energy. I can design the circuits, and they can be self-power. And with this, I believe that we are contributing for what we expected to save is that the climate change that we are suffering today, where the Siberia is one of the coldest places on the earth, is on fire. The Amazon, one of the wettest place on earth, is on fire. Fires are burning across the planet. Why? Because we don't take care about the disease. And disease is how we can promote more and more the green energy. So this is, and we have to take care about this because there are no planet B. We are just on this planet, and we have to see how we can really circumvent and how we can really move further for a better world. And for this, I think that we have to exploit the best as we can the electronics, use green technologies, try to avoid the technologies where you have to put a lot of money, like the ones that you have based on the silicon technology, where you have to have clean rooms, where but try to see chemical-based processes where everything is easier, is affordable for us. And of course, when making things, try to make using sustainable materials. And this is something that is important for all our lives. And with this, I would like also to thank the supporters of all our developments. That goes from a broad range of projects that in which we are involved, and also the companies which are also sustaining all our developments. And in this case, particular, the European Research Council, as well as the Synergy project, where all this type of developments that I share with you, we are trying to share with our European colleagues in the sense how we can really integrate the different type of green energies in a powerful, sustainable source. Thank you very much.